Assalamualaikum and good afternoon all. Can you hear me and can you see my screen?
We can hear that, but we cannot see your screen.
Hello, can you hear me?
Yes, doctor.
Alright. Okay, we will begin our lecture today as I have informed you. Today's lecture is only 1 hour and I will try to make it less than 1 hour so that you can have some break before your online test at 4 p.m. today. So welcome to lecture 9, greedy algorithm, and the outcome for today's learning is we understand about the greedy algorithm. Yes?
We can't see your screen.
Oh, you cannot see my screen? Okay, can you see my screen now?
Yes, doctor.
Yes, doctor.
Okay, thank you. So, we will learn about greedy algorithm through three different problems. And as the introduction for greedy problem, greedy itself is another strategy, just like divide and conquer strategy. We can have different algorithms and we just inject the greedy algorithm inside that particular algorithm. So the entire algorithm will include greedy algorithms as well. So for those of you from AI, right? AI, you do have different approaches to, different strategies to. For instance, AI, you have the incremental learning, where you, whatever problems that you are trying to resolve, you have your own rules to solve that, but you inject some new strategies. For instance, incremental learning, or you have self-adaptive learning, so that we will enhance the performance or the accuracy of the result. So in here, the greedy algorithm. So today we're going to learn the greedy algorithm. As I said, it's another strategy to resolve problems, just like other strategies such as divide and conquer. So greedy algorithm always choose the best solution at the moment. Why we say at the moment? Because when we want to use greedy, one of the property is we can break it under several local choices. So for instance, this is the problem that you are trying to resolve. This problem, it wants to sum up the highest, wants to find the highest summation. Okay, so the entire thing here is called global. And then we have some of local problems here. These are the local problems. Okay, when we mention the word optimal means the best solution at that moment. So for this problem, we want to get the highest summation. So what we do is we see the first local. Okay, so between 7 and 4, being greedy, in this case we have maximization problem. So when we want to maximize it, of course we will choose the highest. So 3 plus 7, it will be 10. So from this, we will have another local where we need to find the optimal choice at this stage. So of course we will choose 20. So we will have 10 plus 20, we will total up to 30. So 30 is the maximum to do the entire addition. So in here, we can see that we make local optimal choice at each stage with the hope of finding the global optimal solution. So as the introduction, greedy algorithm can resolve optimization problem. So what is optimization problem? So we can divide optimization problem into two. The first is the problems which require minimum result. We call this minimization problem. So example, you want to cover a journey. You want to travel the entire world and you want to cover it with the minimum cost. Because being greedy, you do not want to spend your money on unnecessary things. So we need to find the minimum cost. So the optimization is to find the minimum cost. Or you want to travel with minimum distance to reach a destination. So this one, it might sound familiar with your group project where you need to find the shortest path. Next one is the problem which require maximum result. We also call this maximization problem. So for example, a thief wants to steal maximum amount of item. Okay, they want to steal the maximum value of an item. We will discuss it about this later. Or to select a maximum number of activities. We will also discuss it in another problem. So at this point, you just need to know for each problem, they can have more than there can be more than one feasible solution. For example, for your group project, we have 5 feasible solutions for one customer. Okay, we can have more than one feasible solution. But we only have one optimal solution. Okay, so the optimal solution we cannot have multiple solutions. But let's say in your group project, like those two possible routes, right? Give the same minimum distance, then means that you have the choice. But the optimal solution always like one particular distance in that example. So when according to the Oxford Language, optimization is the action of making the best or the most effective use of a situation and resources. So for greedy algorithm, we can resolve optimization problem. In this course, you will also learn another algorithm which is dynamic programming, which able to resolve the optimization problem. So let's see the pros for greedy algorithm. First of all, it is simple, easy to implement, and is fast in terms of the time complexity. However, we have the cons which may not be able to provide the global optimal solution in the end. In these cons, right, later in this course, we will learn about the dynamic programming. The difference between greedy and the dynamic programming is when greedy, once we decide this path, right, we cannot reconsider the other path. But for dynamic programming, it will be able to reconsider the other path. So let's take a look at the cons of the greedy algorithm. For instance, we have this value. Although, okay, so we have 3, 4, 7. So at this stage, we will choose being greedy to solve a problem to get the largest summation from root to leaf. Being greedy, we will move to 7. Okay, for your information, this is slightly different than our previous slide. So we will choose 7 instead of 4. And then after we choose 7, we will choose 11 because 11 is bigger than 9. But currently, greedy answer is we will go 3, 7 and 11. The total we will get only 21. But in actual, we can do better than this because in actual answer, instead of going to 7, we will plus 4, 3 go to 4, so 7, 7 plus 20, 27. See? So if in this case, solving over here is the optimal solution locally. But in global, we will not get the optimized result, which in this case, maximum. So we can conclude that some locally optimal at each stage do not provide global optimal solution. Alright, so this thing will be solved via other algorithm. Graph also able to resolve some of this, and also the dynamic programming could also resolve this, which we will learn later. But in this lecture, we are just going to focus on the greedy algorithm because of the pros. So for the first problem that we're going to try to use greedy algorithm, it is called an activity selection problem. Okay, and then secondly, we will learn about the knapsack problem, and thirdly, about the data compression using Huffman code. So let's take a look at our first problem. The problem of scheduling several activities that require exclusive use of the common space. So for example, if you still remember our faculty, all activities we need to use the BK2 at our faculty in UM. So example, we have activity 1 is meeting among lecturers. The lecturer insists to use that BK2. And then the second activity is to do active learning using drone. And then maybe the algorithm tutorial for group number 6. And then we have other activity. Okay, so all this needs to use BK2. So we can use greedy algorithm to identify the maximum number of activities that can use that the BK2 in a day. Okay, we want to find the maximum number of activity. So each activity has start time and finish time. So these are all the activities. There are 11 activities. And the start time is 1 and the finish time is 4. So this 1 and 4 can be hour, can be week, can be month, okay, can even be in minutes. So considering the following set of S of activity, what we need to do before we inject greedy method is to sort everything in order of the finish time. So all of these activities are sorted based on their finish time. This is the rule that I explained before. The BK2 can only be used by one activity at a time. So if we have two activities, for example, AI and AJ, the start time and the finish time for both activity cannot be overlapped. So the goal here is to select the maximum number of activity without any overlapping. In here, in the common book, they call it mutually compatible activities. If we just look at a glance, we can see that the A3, A9 and A11 are mutually compatible activities. However, 3 activities is not the maximum number of activities in this case. So we can run the algorithm. Well, of course, we can find it ourselves over here. Okay, but if we want to automate to find the maximum number, then we can use the activity select that has been injected with the greedy method. So after running the greedy method, we can see that they can have maximum of 4 activities in so we have the first activity start at 1, finish at 4, and then we can have the fourth activity which start at 5. We cannot have activity 2 because activity 2 will be overlapping with activity 1, whereby activity 0 will also be overlapping with activity 1. So the next will be, since this will be completed at 4, activity 4 can start at 5 until 7. So you can see here 3, 5, and 6 will be overlapped with activity number 4. So we need to exclude here. Then once we finish at 7, then we can start at 8. Finish at 11 and start. The next activity can use the BK2 since they start at 12 until 16. So this is not the only maximum that we have. You can still find, if you try, you can still find, but whatever it is, the maximum is 4 activities. using greedy. So before we proceed with the next problem, are you okay with the activity selection problem?
Doctor, I have one question.
Mm-hmm.
Can can 1447, I mean the start time at the end time is equals to the start time.
Yes, it can. It can.
Okay, can be.
Mm-mm. Because very quick question. Because that one, if let's say we want to that can be done too. In this question, we just want to maximize the number of activity. There can be questions where we want to maximize the amount of time. Okay, so it will be different. Whatever it is, this is just an example of how greedy can be solved to use the problem. But in order to highlight to you, right? Okay, so the first problem, right? Is it maximization problem or minimization problem? Anybody? What do you think?
Maximization.
Okay, thank you. It is maximization problem. Okay. Hold on, I cannot see the chat. So for it will be clearer to you when I explain about the knapsack problem. Okay, knapsack problem, in the end of this, you will tell me is it maximization or minimization. But I think in this example, it will be clearer for us on what is greedy. So for greedy knapsack problem, we have a situation here. This is a greedy thief. This thief is very greedy. And a thief is intend to rob a store. He has a knapsack. Knapsack is a bag that has certain capacity of W. So this knapsack can only hold the capacity of W. So this W can be the weight or can be the size of the bag. Okay? But in this case, it is weight. He wants to put the item in the knapsack that hold the most value without exceeding the weight. And the rule here, he can only steal 1 unit per item. So let's say we have 3 different items. He cannot take item 1 for several units. It's only 1 unit per item. So being greedy, he wants to hold the most value. Okay, he wants to steal the most valuable item in the store. So right now in this lecture, we are trying to help this thief to identify which items he needs to steal. So let's say there are 3 items here. And these items are this item has different weight, 10 kg, 20 kg, and 30 kg. This is the greedy thief who wants to take maximum value of item. but his knapsack can only hold maximum of 50 kg. So being greedy, which item should this thief steal?
Item 3.
Item 3, that will be 30 kg. So he has another 20 kg. So which item that he can pick?
2 and 3.
Item
2
2
and
and 3.
3. Okay, so he will take item 2 and 3. So when he takes the item 2 and 3, the value that he got, he's able to steal is 220 ringgit. So just now, what you just did is 0 to 1 knapsack. Okay, we can take it or we can leave it. And as we agreed just now, the thief should take item 2 and item 3, which hold the value of 220 ringgit, and he won't he utilized all of his knapsack. Okay, like I said earlier, for optimization problem, we can have several, we can have feasible solution, but only one optimal solution. Okay, optimal is the maximum. So currently, this is take it or leave it. We also have another strategy, is still greedy strategy, which is fractional knapsack problem. In this case, we want to, we can take the fractional, means we can cut this item into fraction. So there are 3 steps to do here. First step is to calculate the ratio, which is the value divided by the weight. Currently, for item 1, 60 divided by 10 is 6. So the ratio is 6. Item 2, the ratio is 100 divided by 20, which is 5. And item 3 is 120 divided by 30, which is 4. The highest ratio will be the best. Okay, because this particular one, although it is the ratio is 6, so it is the he can hold the best value. He can steal the best value. Then what you need to do next is sort the item highest ratio to lowest ratio. So in this case, it's already sorted. Okay, we have ratio 6, ratio 5, and 4. So the third step is to identify which one that we need to do the fraction. So at a glance, when you look at here, we can tell the thief, okay, first you steal this thing first. So we have 10 kgs. So the knapsack weight is now already occupied 10 kg. And then we should be getting the next highest ratio, which is 5, not 4. Okay, so this 5, so it will be 30. So we have 10, 20. In total, we have 30 kgs in the knapsack. However, how much how that the knapsack of this thief can hold?
50.
50. But so if we take the entire item here, it won't fit his bag, right? So what we can do here is step 3 is to take item with the highest ratio and then just take the fraction if cannot be taken as a whole. Okay, so currently because he only has 20 kgs left, so we can take 1/3 of this, the third item. Okay, and then when we calculate the total using fractional knapsack problem, we are able to the thief able to steal total value of 240 instead of 220. So in this case, 0 to 1 knapsack problem does not yield an optimal solution. However, the fractional knapsack problem able to yield an optimal solution. Okay. So this is how greedy works. Right now, is it maximization problem or minimization problem?
Maximization.
Yes. All right, thank you. Next is the third problem, which is called Huffman coding. This Huffman coding, the purpose is to compress data. So we have a lot of data that we want to compress them without losing any information. So using injecting greedy algorithm into the Huffman coding able to save 20 to 90% of the memory space. It is depending on the characteristic of the data being compressed. However, in this lecture, we simplify things to character. So for instance, the data that you have is only A, B, C, D, E, F. These are the data that you want to store and you want to compress them when you are not in use. Or maybe the zip file, they might be using this algorithm too. Well, before you want to send to email it, you need to do the compression, right? So this is the example of the algorithm that they use. So suppose we have 100,000 character data files that we want to compress. So for each character, we need to assign 3-digit code. So here, A, we have 45, which is in thousand. 45,000, 13,000, 12,000, and so forth. So when we plus all this, right, 13,000, we will get 100,000 characters, and we want to compress it. So for each of the character, when we want to compress it, we will assign to a code word. This is code word. In this example, it assigns to the fixed length of the code word. So the total bits means after the compression, okay, we won't go so far about this code word, okay, but the concept is in data compression, okay, the concept of data compression is the total bits is the frequency of the character. We need to times the length of the assigned code word. For example, here we have the A, which is 45,000 times 3, it will be 135 bits. So, using the fixed 3 bits code word, what is the total bits after this file is compressed? How we gonna calculate it is, for example, this is the total bits in 1000. 445 multiplied by the 3, okay? The length of the assigned code multiplied by 3 is 135. 13 times 3, 39. 12 times 3, 36. 16 times 3, 48. 9 times 3, 27. And 5 times 3 is 15. So in total, when the total bits for us to do the compression using the fixed length code word is 300 bits. So from here we know that if each character is assigned to a fixed 3-bit code word, the file can be encoded in 300,000 bits. So we want to do better than this. So that is why we want to use the Huffman coding algorithm. Okay, this Huffman coding algorithm, like I said just now, they apply the greedy method in it. So this is not a greedy method yet. In order to make the compression smaller, to use the Huffman code, this is the code. What we need to do is, first step is to create a Huffman tree to assign the most frequent character to the least number of the code word. You need to do some reading why not all of the word code word we can just multiply by 1. Okay, or 2. You need to read about it. But the concept of the data compression is to make the bit smaller. We assign the most frequent character to the least number of the code word. So in the previous example, what is the biggest frequency? Which character is it that has the biggest frequency?
A.
A. Okay, so this A, instead of fixing the code word to three digit, right? Then we can assign maybe to 1. Okay, so in order to do this, we need to build a Huffman tree using that algorithm, but I just illustrate what is the output. The step 1 is, since it is greedy, we need to pick the 2 character with the lowest frequency, because this is a minimization problem where we want to pick the least. Right now, this is the same frequency of word as the previous example where A, we have 45,000 of frequency. Next, so we search here and find the lowest frequency, which is E and F. So we put E and F here, and inside the node you put the frequency. Next, the root node is the sum of the 2 leaves. So 5 plus 9 is 14. Then we get the first root node, which is, we call it N1. So currently, N1 will be the feasible solution. Okay. Remember, just like your group project, we have several feasible solution. Okay, like for customer 1, they have 5 feasible solution. But being greedy, we want to take the smallest. Okay, so these are the feasible solution, which is 14. Then what you need to do next is to find the lowest frequency within this. Which are the lowest frequency apart from E and F that is already written in the tree?
C.
So C and B would be the lowest. So what we need to do is we write the C and B at the tree. The common question is, where do we want to place? Okay, so my answer is, as it gets bigger, it needs to shift to the right. Okay, so we have 12 and 13 here. So we have another root node and 2. So we strike this B and C because we have done this. So we pick the smallest 2. Currently we have 45, 16, 14, 25 and 30. So you can see here the smallest is 14 and 16. 14 is the N1. Okay, so this is N1. Can you see here? Hold on. Okay, so this 14 with 16. So 14 is already here. We add 16 here. Then we will have a new root node which is 30. Understand? So far. So we slash out the D. Okay, we have done the D. So now we have 45. All these are done. 25, 30, and 55. So being greedy, we need to pick the least one. So this N2 and N3, N2 and N3, we need to sum them and become a new root node which is N4. N4. Okay. So right now we have only 2 left, 45 and 55. So this 45, we add with the 55 and we will get the new root node which is 100. So currently we have created our Huffman tree using greedy method. Right now, the purpose of us doing this is to assign the code word. So for us to do the code word, what you need to do is you need to put the code 0 on the left and 1 on, at the right. Like this. 0, 1 at the right. 0 at the left, 1 at the right. Okay? To each of the local. So we already have this. Next, the last step is to identify the code word. Currently, instead of having the fixed length of code word like the original, we will have the variable length of code word. In order for us to know the code word, so for character A, we've searched for character A, the code word will be 0. So the code word will be 0. Next, we want to identify the code word for character B. So we can try to search B. So what is the code word for B is, you need to read from above. 1, 0, 1. So this is 1, 0, 1. The character C is here. That is why the variable length of code word is 100. D. Here, the character is, the code word is 111. So that is why I just write here 111. And E, you can see here E is right below, okay? Because we want to make sure that the right below has lower frequency. So lower frequency can afford to have longer length of code word. So E we have 1101. Oh, sorry. 1101, and lastly for F we have 1100. So we can see here for 45, which is the character for A that has the highest frequency, will have only one digit of the code word. So in order for us to calculate the total bit, remember we need to multiply the frequency with the length of the code word. So 45 multiplied by 1 is still 45. 13 multiplied by 3 is 39. 12 multiplied by 3 is 36. 16 multiplied by 3 is 48. 9 multiplied by 4 is 36. And 5 multiplied by 4 is 20. So in total, we will get 244 bits. This 244 bits is smaller than the previous one when we did not build our Huffman tree. Because previously, when we used the fixed length code, this method require 300,000 bits to code the entire file. So when we do use the Huffman code, we can do better, okay, to get down to 224,000, which will able to save approximately 25% of the memory space. So again, today when we learn that selecting a suitable algorithm can also save the memory space. Okay, so that's all for our lecture today. You will have 10 minutes to prepare for your test that will be commencing at 4 o'clock to 5 o'clock. Everybody, please take your attendance, record your attendance in Spectrum. Before we finish, do you have any questions pertaining to this lecture? Everybody okay? I can see that, okay, please respond if not okay. Okay, if you're quiet, I assume that you're okay. We get a very good attendance today. So I just want to inform you that please do not record your attendance if you do not attend the lecture. Okay. All right. So thank you all. Good luck for your test. I wish all the best to you. Bye.